Before break, we talked about how to connect a server-side script written in Python to a database, and that's almost all we're going to do with the server side. We may actually come back and talk about how to use PHP to write server-side scripts or talk about REST architectures, but as far as I'm concerned, we've covered as much as we absolutely have to on the server side, and now it's time to change our attention, to shift our attention to something a little bit different, and that's a way that the client and the server can communicate. Right now, the only technique we have for getting information from the server or for sending information to the server is to use forms. And forms have some big drawbacks. So in the next couple lectures, we're going to talk about how the web browser can actually communicate with the server a different way. But first, we have to go back and review some of the features of JavaScript. Despite the name, JavaScript is only loosely connected to Java. Java is an object-oriented programming language, and it has a lot of object-oriented programming features. And in particular, in Java, all variables have to belong to a class. So Java uses something called class-based object-oriented programming, and JavaScript doesn't. It uses something slightly different, and that's what we're going to talk about today. So first, we need to define some terms. When I talk about object-oriented programming, what do I mean? So let's start by talking about what an object is. An object is really just a bunch of variables that we've packaged together into a single unit, into what we call in computer science a data structure. So it's a data structure that contains a bunch of variables that are related in some way, and also it contains some functions for updating and manipulating those variables. So for example, I might have a user object that stores data about a user. And that might include the username and the password. It might include how long the user's been logged in. It might have other information like a real name or a phone number. But all of that information gets packaged together into one object that I can talk about called a user. And I can have many different users in my system, and each of those users is a separate object. There's a lot of terminology here, so bear with me. When we talk about a variable inside an object, we're going to use the word property. So a property is just another way of saying a variable inside an object. So for example, a user object might have a username property. A method is a function that's stored in an object. So for example, there might be a function that checks a user's password. And so that check password function could be a method of the user object. And when we talk about a bunch of objects that are more or less alike, we call that a class of objects. So what is a class? Well, it's really just a cookie cutter for stamping out a bunch of objects. And we want those objects to have the same properties and methods. So objects in a class all have the exact same properties and exact same methods. So for example, all users have a username and a password and a check password method. But each object in the class has different values for those properties. So all users have a username, but one object may have the username Bob, and another object may have the username Fred, and another object may have the username Sally. So they have different values for the properties, but they all have the same properties. We're going to see that in JavaScript, that's not strictly enforced. So in class-based object-oriented programming, or OOP, we have some special methods that we talk about and some special properties that we talk about. In particular, we have a method we call the constructor. And in class-based object-oriented programming, the constructor is a method that initializes the properties of an object to some reasonable default. So for example, if I have a username property, my constructor might set the username to anonymous or no name, or it might set it to the empty string. In JavaScript, the constructor is used in a different way. We're going to see in a bit that in JavaScript, the constructor actually creates the object, which makes more sense in terms of the vocabulary, but is very different from most other high-level languages. Okay, two more terms that we need, accessor and mutator. An accessor is a method that retrieves the value of an object's property, and a mutator is a method that modifies an object's property. So if I have my username property and I want to change it, I can change it with a mutator. If I want to know what the username is for a particular object, I can use the accessor method to get that value. So in Java, these are sometimes called getters and setters. In C and C++, we call them accessors and mutators, and that's pretty commonly used in the JavaScript world too. Some people call them getters and setters. Some people call them accessors and mutators. I'm going to use the terminology accessor and mutator, so if you hear me say that, you need to know what that means. Some of the properties in an object are unique to each object. For example, the username is different for each object. But sometimes values are shared by the entire class of objects, and we call those static values. And static values belong to the entire class of objects. So for example, I might have a minimum password length. And I might set that on the user class rather than on a particular object. So the minimum password length would be the same for every user. Another important idea is the idea of inheritance. In an object-oriented programming language, inheritance is really important. Inheritance is what gives object-oriented programming advantages over other programming paradigms. And inheritance is the ability to take a class of objects and extend it by adding new properties and new methods to create a new, more complex class. So for example, I might have a user class, and I might extend the user class to create an admin class that has more power. The admin has properties that the user doesn't have. It has methods that the user doesn't have. For instance, it might have a create account method. Normal users can't create new accounts, but admins can. But admins also have all the properties of a user. An admin has a username and a password and a check password method. Java is class-based, and so it uses classes and constructors and getters and setters, or accessors and mutators in my parlance. JavaScript is not class-based. JavaScript does provide object-oriented programming features. It's what we call a multi-paradigm language. You can use object-oriented programming in JavaScript, or you can use other programming paradigms. You can use procedural programming, for example. But JavaScript doesn't use classes. Instead, it uses a different style of object-oriented programming called prototype-based object-oriented programming. And it's odd. It's weird. I don't know of any other language that does it this way, but it's actually really kind of clever, but it can be confusing if you've never used it before. So in prototype-based object-oriented programming, we don't have classes. We don't define what an object looks like up front. We don't say all users have a username and a password and a check password method. Instead, what we do is we create a prototype object. And we give that object some default values for its properties, and we give it methods. And then, instead of using classes to create a bunch of objects, we take that prototype and we copy it a bunch of times, and the copies become our instances. So a prototype is just an object that has default values and methods, and it's used only to produce other objects with the same methods, but whose properties we can then change. So for example, I could create a prototype user, and then I could copy that user a bunch of times and change the first copy's name to Bob, and the second copy's username to Fred, and the third copy's username to Sally, and I could set all the passwords, and that's how object-oriented programming would work in JavaScript. We also have inheritance, but because we don't have classes, it looks very different. Instead of having a class inherit from another class and then creating objects of the new class, we take a prototype and we add methods to it and we add properties to it to create a new prototype. And then we use the new prototype and we make copies of the new prototype to create objects that inherit from the old prototype. So this is how JavaScript works. So if we want to create an object in JavaScript, we use the new keyword, just like you would in Java or C++. So for example, I can say var Fred equals new user. And what will happen is that JavaScript will look for a constructor function named user, and it will run that function, and that function will return a user object, and that user object will be named Fred. So basically, it's making a copy of the user prototype, and it's naming that copy Fred. Now, in order to access an object's properties and methods, we use dot notation. This looks, again, just like Java or C++. So we could say Fred.name is Frederick, and that would change Fred's name or username to be Frederick. We could actually then fetch the name by creating a new variable called name and setting it equal to Fred.name. That would copy the name from Fred and put it into a new local variable. If we want to call a method in our new object, we can say Fred dot and then the method name. So here I can check whether Fred is logged in by calling Fred.checkPassword, and in parentheses I'll put in his password, frog hopper, with 0s for O's and a 3 for the E. And that'll return hopefully true or false, depending on whether he is that is the correct password. Objects can also be passed to functions. So suppose I make another user named Kelly, and I set Kelly's username to butterfly08 and her password to secret. A really secure password, let me tell you. Never set your password to something so simple. And then I can call the login function and pass in Kelly. This is sort of the advantage of using objects. I can have a bunch of different variables, the username and the password, but they're all grouped together into one object, in this case named Kelly. And so instead of passing in the username and the password and a bunch of other properties all separately, I can just pass Kelly and they all get copied over. I can also copy objects, but I have to be careful how I do it. So for example, suppose I want to take Kelly and make a copy of her and name the copy Susan. The way that I do that in JavaScript is I say var Susan gets Kelly.assign. So why do I have to call this assign method? By the way, all objects in Java provide the assign method. You don't have to write that. It's provided for you. The reason that I have to do that is because of a problem in computer science we call shallow copies. So if you were to say var Susan gets Kelly without the dot assign, and then you were to say change Susan's username to Summer Sailor, and then print out Kelly's username, you would find that Kelly's username has changed to Summer Sailor too. What's happened is that when you say var Susan gets Kelly, JavaScript isn't actually making a copy of Kelly and putting it in Susan. It's basically saying Susan is another name for Kelly. So if I change Susan, I'm changing Kelly, and if I change Kelly, I'm changing Susan. They're both the same object, but Susan and Kelly are different names for that object. This is a little bit confusing. The key point to remember is if you want to actually make a copy, you have to say .assign at the end and call the assign function. Or you'll do a shallow copy where it copies the name instead of a deep copy where it copies the values inside the object. One of the cool things about JavaScript is that in JavaScript, everything is what we call a first-class object. So, for example, string variables are objects, and they have properties. So, for example, if I create the string str, and I assign it the value I am a thirsty camel, I can say str.length, and that will tell me the length of the string. Every string has a built-in property named .length. Strings are objects. That's fairly typical. In a lot of languages, strings are objects. In Java, there's a string object. In C++, there's a string object. In JavaScript, however, everything is an object. At least all variables are objects, including numbers. So here, I'm going to create a number. I'm going to set it to the value 22. And numbers are objects, and so they have methods. One of the methods that a number object has is the toExponential method. I can say num.toExponential of 2, and this will print out, with 2 decimal places of precision, 22.00 times, actually it'll print, I think, 2.2 times 10 to the 1 or something like that in engineering notation. So it'll actually print out in a different format. Even functions are objects in JavaScript. Over on the right, I have function sum of x comma y, and it returns x plus y. So pretty simple function, but the function itself is an object, and that means that the function can have properties. And one of the methods that a function has and that I can use is the toSource function. So here, I'm using alert to pull up a dialog box that will print out a message, and the message I'm printing is sum.toSource. And that will actually print out the source code for this function. It's actually going to print out the words function sum of x comma y, parenthesis, curly brace, return x plus y, closing curly brace. That'll actually show up on your screen because it'll convert the function object into a string representing the source code. There's other things that you can call too. This is kind of neat stuff. JavaScript also provides a bunch of built-in classes that you can use. They're useful. It provides a bunch of collections. So a collection is a fancy data structure that can contain multiple different items. So we've already talked about arrays a little bit. We're going to talk about them more in a minute. You can have maps, so we can map a number to a string, or a string to a string, or a number to a number. We can have relationships between things and represent them using a map object in JavaScript. We can have sets of things. A set is sort of like an array, except that I can't have duplicate values in a set. So if I have two of the same object in my set, JavaScript will throw one away. We can have iterators, which are useful for looping through the things in a collection. We also have a bunch of basic data types. There's a date object in JavaScript that we can use to represent dates and times. There's a number object that we can use, and a string object that we can use. We've already seen that up above. And finally, there's also a math object that just contains a bunch of useful mathematical functions. It's really not an object in the object-oriented programming sense. It's more of what we call a namespace. Basically, it's just a way to group a bunch of methods together so they're easy to find. Things like the square root and the tangent. So let's talk about a few of these. A date's an object that you can use. It represents a date and a time, even though it's called date. I can create a new date by just saying var now gets new date. The date prototype sets the current date and time. Or it sets the values of the date object to the current date and time. So if I just say new date, it'll give me now, right now, today, at this moment. So it happens at the moment to be 10:35 p.m. on January 3rd. So if I printed out the month, it would tell me January. You can also create a date object for a different time. You can say var do gets new date, and in parentheses, we can pass in some values to that constructor function. So we can say make a new date for the year 2017 in January on the 12th. And the time should be 23:59:59. So 1 second before midnight on January 12th. Date also provides a bunch of methods that we can use. We can get the day, we can get the month, we can get the year, the hours, minutes, seconds. We can also convert the entire thing to a string, which is useful for printing it out. There's a bunch of others, too, that you can look up. We've already talked a little bit about arrays in JavaScript, but an array is an object. And so it has properties and methods. To create an array, we say new array. So for example, I can say var list gets new array. And that'll make a new array named list. I can also create arrays using some special JavaScript syntax. So here I can say var list2 gets, and I can use square brackets, 1, 2, 3, 4. Or I could make a list of strings. Var list3 gets in the square brackets the string Thomas, the string Natalia, the string Ashley. Notice that I put those in double quotes because they are string literals. Strings in JavaScript are also objects. So this is an array of objects. And an array is an object, so it's an object containing objects. Maybe that's confusing, but I think it's cool. Arrays can be accessed using the array bracket operator. Java provides certain kinds of operator overloading, sort of like C++ does. This is another way it's different from Java. Arrays can be accessed using the special square bracket operator. So I can say name gets list3, square bracket 1, and that would give me Natalia. Again, we count from 0, so Thomas is in position 0, Natalia is in position 1. Every array also has a length property. So I can say varlen gets list2.length, and that will tell me that the length of the list is 4. Notice that length is a property, not a method, so I don't put parentheses at the end. I just say .length, no parentheses. Arrays provide a bunch of other useful methods. For example, I can use concat and then another list to take one array and tack it onto the end of the first array. So I could say list.concat of list2, and that would take all of my strings and add, or my numbers, I guess, and add them to my first list. Fill is a function that takes a value, and it replaces all of the values that are already in the array with that value. So if I fill with 5, no matter how many things I have, they're all going to turn to 5 when I fill. Filter takes a function as a parameter, and I have to code that function. And what that function will do is basically return either true or false, and it'll look at each thing in the array, and if it passes through that function, if that function returns true, it'll keep it, otherwise it'll throw it away. So this is a quick way to maybe discard all the odd numbers. Right? I can keep the evens and throw away the odds by having an even function that returns true if it's even, false if it's odd. And then when I call filter, it'll throw away all the odds. The join function will take all of the things in the array and make them into one long string. And index of will find a value in the array and tell me where it is. What position is it at? Again, starting from 0. Map is another data structure. It associates keys with values. The keys and the values can be any type at all. So I could have keys that are numbers or values that are numbers. I could have keys that are strings or values that are strings. I can map strings to numbers or numbers to strings or numbers to numbers or strings to strings. I can map dates to strings. I could map maps of maps to strings of maps or something like maps of strings. I can do a lot of complicated things. So here's an example. I can create a map named nums, and then I can call the set method to map the number 0 to the string 0. I can map the number 1 to the word 1. And then I can use an alert box to print out nums.getOf1. That will look up 1 in the mapping and say, OK, that's ONE, and it'll print ONE. Map also provides a clear method, a delete method, an entries method that gives you the entire map as a list of key value pairs, get and has functions, and a set function. Speaking of sets, a set is another object that JavaScript provides for you. It basically is like an array, except that you have to have unique values. So here I make a new set named names, and to those names I add Bob, John, and Bob. The first time I add Bob, it'll put Bob in the set. The second time I add Bob, it's going to ignore it, because Bob's already in the set. So this is sometimes useful for removing duplicates. You've already seen that there's an add method, there's a clear method, a delete method, a has method, a values method, and many other methods that you can look up online very easily. Another important object is an iterator. It's an object that is usually included by default along with the collections. So it's sort of a nested object, an object inside an object. You can create your own iterators if you create your own collection objects. The only thing that an iterator is guaranteed to have is a method called next that returns the next item in a collection. It's basically a way to loop through things. If you make an object and you give it a next method, it is an iterator. And if it is an iterator, then you can use it with a for loop. So a for in or a for of loop. And JavaScript will do the right thing, which is kind of neat. So how do you make your own classes in JavaScript? Well, you don't define a class, you make a prototype. And the way that we do that is by defining a constructor function. So for example, I'm going to make a function named ship that will create a ship prototype and return it. Actually, I don't return it. That happens for me automatically. Instead, I'm going to use something called the this pointer, or the this object, to set up the default values. So here I'm going to set the type of the ship to destroyer, the class of the ship to Sims, the name of the ship to USS Russell. This was an actual destroyer, I think, from World War II. I'm going to set the latitude and longitude both to 0. I'm going to give it a method called move that takes a new latitude and a new longitude and changes the latitude and longitude to be the new latitude and new longitude. I notice I have a typo in this code. Let's fix that really quick. There we go. Now it's correct. And now that I've got this function, I can create ships. So for example, I might create a ship named Morris. I can say var Morris gets new ship. When I do that, it's going to run this ship function to create a new object that has all these properties, and it's going to return it and name it Morris. Then, if I were to print out the name, it would print out USS Russell, but I want this to actually to be the USS Morris. So I say morris.name equals, and I can change the name to USS Morris. And then I can use the move method to move Morris to latitude 37.075978, comma, and longitude negative 76.521719, which I think is the latitude and longitude of the Norfolk Naval Shipyard. Maybe not. I looked something up, and I think that's what it was. So in order to do this, we use the this keyword. And that's just a way of referring to the current object, either the one that we're currently making or the one that we're currently using. So for example, if I call a method, inside that method, this will refer to the object that the method belongs to. So in the constructor, we use this to set the initial values and to create the methods. Inside a method, we can use it to modify or retrieve the properties of the current object. But if it's inside the property of an object, then we can use that to refer to the object itself. So those are three uses of the this keyword. So in summary, JavaScript is an object-oriented language, but it's an unusual one. It's one that uses prototypes. JavaScript provides some built-in classes for lots of important data structures, such as arrays and maps, but also for things like numbers, strings, and dates. It also provides an iterator object that's useful. There are no classes in JavaScript. Instead, we create a constructor function that creates a prototype object. And we can use that prototyped object to set default values, and we can make copies of the prototyped object to stamp out instances of the class. Methods are added directly to the prototype, and default values are set for all the properties in the prototype. I hope that you're having a lot of success with your new lab. Please be working on the final review. You don't have a lot of time. Our final is next week. So we have just 1 week left to prepare for that final. I will see you next time.